Hello, welcome to the second of the calculator tutorial series. This time we will talk about Gauss-Jordan elimination. As always, on the right we have the subtopics, and above we have the steps and the important things, or what we have a snapshot of the calculators. Gauss-Jordan elimination can be used for different things, but we focus on how to solve the system of equation like this. If you watch the first video, we use the same example in this section, so we should know what we get already. But this time we use the Gauss-Jordan elimination instead of the inverse as the first video. First, from the system of equation, we have to write that as the matrix matrix, which is just like a matrix, except we draw a line to separate the coefficient on the left and the constant on the right. So that's a matrix or matrix matrix. If we put that in the calculator, it has 3 rows, 4 columns, and now we enter the numbers. When it's names, then I can recall that and look right. Gauss-Jordan elimination, we will eliminate this into the reduced row echelon form, or RREF. In the calculator, if we go to math, we go to option RREF, and we definitely can do that, and we apply that option into the matrix A. We have that, and that will be X, Y, and Z. So that is relatively easy. However, we're not going to use the calculator. We use the calculator, but not that option. What we use is the program in the RowOps. If you don't have this program, in class we can transfer the program to your calculator. Relatively easy. Right, now we start with that matrix, and we already have that, which is good. Now we go to the RowOps. Instruction for the RowOps, again, you can find above document, right above the screen. Anyway, so we hit program, and because the first step we already entered the matrix in the calculator, so now we can go to the second step, hit program, choose that option, RowOps, and we can begin. Alright, hit enter. It will ask you to which matrix do we use. We use the matrix A because we enter that in the matrix A. If you make any mistake during the process, which is a very long, tedious process, we quit the program, choose option 7, and go back to the program. But that time we're going to use matrix E. Matrix E is going to store the last corrected result. So, and then we don't have to start from the beginning. Right, now we choose the matrix A. Hit enter, and they give you the matrix A. That's what we have here. And we hit enter again, and it asks you to hit enter to continue. So we do that, hit enter to continue. Here are the operations we can choose. We can swap 2 rows, add a row to another row, multiply a row, multiple one row, add to another one. Usually we're going to use the first, the third, and the fourth option. We usually don't need to use the second function. Right, so those are the function, the operation. The steps will be the document right below it. So we're going to get the 1 first, and then we'll turn everything to 0. So in order to do that, we need this to be 1. So this need to be 1, and this 2 need to be 0. That's the first step. Right. Sorry, the camera sometimes they do the autofocus and it's just something. Anyway, so we need to have 1 here. The way to get 1 here is we can divide the whole row by 2. I don't want to do that because I will end up with fraction. Instead, I will swap this row with that row. So row 1 and 2 will interchange. So the operation will write row 1 interchange with row 2. Right, so that means row swap. So we're going to choose the first option. The first row to swap is row 1. Swap with the second row, row 2. Hit enter. That's what we have. We can copy the result. Right. 1 0. Right, so we have the leading one. This is called the pivot one also. Now we're going to use this one to turn the others to 0. To turn anything to 0, we're going to use the opposite to this number. To eliminate the 2, we're going to use opposite to that. Opposite of 2 is -2. Next, we multiply -2 into the row that has the leading one, which in this case row 1. And after that we will add and replace. When we add and replace, those two matrices should be the same. Since we try to eliminate the 2 which is in row 2, we'll add to row 2 and replace into row 2. After that, this will go to 0, and then this will go to 0 using the opposite to that, -3. Multiply to the row that has the 1, row 1, and we'll eliminate the 3 in row 3. Yeah, we can do 2 of them at once. So hit enter to continue. Now we choose option number 4 because we multiply a row by something and then add to another row. Like I said, usually just 1, 3 or 4. I choose option number 4 this time. We multiply row 1 by -2, add to row 2, and we have that. Now you see we have 0 there. We can write that matrix, but I can keep rolling and enter to continue. Option number 4. Multiply -3. I'm sorry. Multiply row 1 by -3. Add and replace to row 3. When we do that, we have zeros. At this stage, I will write that matrix down. Right. For the first column, we have the 1, 0, 0, which is good. Now on the second column, remember we need the 1 to align in the steps. So the 1 here is good. The 1 after that have to take one step down to the right. So we also have the one where we want. After we have the one, we should have 0 here, which we already have. Now we just need to turn this 2 into a 0. Right. Now hit enter to continue. And to turn this 2 into a 0, remember we use the opposite of that. We multiply to the row that has the 1. Now it is row 2. We add and replace to something we try to eliminate. That in row 3. So hit enter to continue. Again, option number 4, multiply to a row and then add. Multiply row 2 by -2 and add to row 3. That. I'll continue on this side. Let's copy that result from the calculator. 1012 01 -1 6 0 0 1 -1. Right. Now let's check for the first column 1 0 0, which is good. The next column 1 and 0, which is good, and the 1 aligned in stepping down to the right, which is good. So that's good, that's good, that's good. So the first 2 columns are done. Now we go to the last column. Since the 1 have to align in steps, so we need to have the 1 here, which we already have, so which is good. What we need to do after that is turn this to a 0 and turn that to a 0, and then we're done. So this to a 0 and then this to a 0. To turn anything to 0 using elimination, we use the opposite to that number. So -1, we multiply to the row that has the 1. Now it's in row 3. We add and replace into row 1 to eliminate it. And we use opposite to this, which is just 1. Multiply to row 3, add and replace to row 1. Hit enter to continue. Option number 4, multiply row 3 by -1 if you happen to enter something wrong, for example. Then we have to go back and do it. So good thing that is still right. So then we have to quick. Now if we go to the matrix E, that is the matrix that we the last state. The bad thing is I already hit enter, so it's not going to be bad. So now we go to this. This time we can just go to the matrix E, will be the last result. Sorry, I messed up now. That's supposed to be a 0, so I have to use -6 instead. Right. So row 3. So like to make a mistake right on this step, I just hit second mode and then we're done, and then just hit 7 to quick, and then we're done. Do not wait until the end. If you hit enter, the result will change. I did that badly, but now let's just go back to E. This day, like I said, I need to turn that to 0, so ignore that. Just need to row 3, we need to turn that to 0, so have to be -6 and not here. Row 2, row 1. Okay, we're good, everything good now. Now we need to do that. Like if you make a mistake, immediately hit second mode. Do not hit enter, because after hit enter, it will store the result in the matrix E, and we cannot go back to that. So it's tedious. If we choose the wrong option like this, then hit second mode to quick immediately. Then we can go back to the matrix and choose the matrix E, and that will still right. Don't hit enter, because when it hit enter, it will change the matrix. We want the second and mode to quick immediately. Anyway, now we turn that to 0, which is this. Multiply row 3 by 1, add to row 2. Sorry, this should be 2. Right. Then we have that. This is done now because we have 1 on the steps, stepping down to the right, and when it's in the reduced row echelon form, we have X, Y, and Z. So that's what we have. Of course, we can also use the REF option, but this doesn't take a lot of work, but it turned out to be very nice. A little bit tedious. Just pay attention. We write out the operation first before we enter the operation in the calculator. Right, that's the first example. Now we go to the second example. Right. And once we're done, we can hit option 7 to quick. Now we're done. First we start this matrices into the matrix matrix, and then we go from there. Right, I need to put that in the augmented matrix, so put that in the matrix A, say 3 rows, 4 columns, 1, 2, -2, 4, 2, 5, 0, 3, 1, 1, -6, 7. Alright, let's see. 1, 2, -2, 2, 5, 0, 3, 1, 1, -6, and 7. We got the matrix. Now we do the row operations. RowOps, hit enter twice. Choose the matrix A to begin. This is what we want. Right. What we see here is we have the one where we want it on the first column, so that's one's good. Now we just need to turn this 2 to 0, this 1 to 0. When we turn anything to 0 in elimination, we use the opposite. So -2, the 1 is in the first row, the leading one in the first row. Now we eliminate in row 2. Use -1 opposite to that, to the row 1 that has the leading one. Add and replace to row 3. Store to row 3. Usually we can write more than one operation at a time, but the calculator can only do one at a time. So option number 4, we multiply row 1 by -2 and then add to row 2. Oops. So that is 0. Option number 4, multiply row 1 by -1, add and replace to row 3. Right, we have that. If we have any fraction or decimal, the calculator, this program will convert everything to fraction, so we don't have to worry about it. Right. Right. Now let's check. We have 1, 0, 0. So the first column is good. Next column, we have the 1 already, which is good. Now turn this to a 0, this to a 0. Which we use the opposite. And then we multiply to the row that has the 1, the leading one, which is in row 2 now. Row 2. And then you can add and replace to the same row 1, which we try to eliminate. Row 2. Right, so we do that. Enter to continue, option number 4. Usually row 2 by -2, add row 1, row 2 by -2, add to row 1. Yep. So we have that. Now 0, which is good. Enter to continue, multiply and then add. So multiply row 2 by 1, add to row 3. You have that. Let's write that result. Right, 1, 0, -10, 14, 0, 1, 4, -5, 0, 0, 0, and -2. Right. Now let's check. I have 1, 0, 0, which is good. First column is good. Next column, 1 and 0, 0, the 1 on the step, which is good. On the next column, we need to have the 1 here. We cannot get the 1 here because that is 0. There's no way you can turn a 0 into a 1. You can turn the 1 to a 0, but not, you cannot turn 0 to anything. And you cannot swap those row either, because if you swap, the leading one here will change, and you do not want to change those leading one either. So we need this to turn to a 1, which we cannot do. So in that case, we have to skip to the next column. So in this column, we need to turn this into a 1, and after that we turn everything else to 0. By the way, we could stop here already, because you have 0x plus 0y plus 0z equal to -2. That's not possible. So we have no solution here already, but let's just continue. We turn that into the 1. Right. And to turn in anything to 1, we just divide by itself. We give you 1. Unless it is 0, 0 cannot turn to anything. So we take row 3. If you divide by itself, like if you divide by -2, then that will give you 1. So enter to continue. We multiply a row, so option 3 instead, by 1 divided by -2. Yeah, that's it. I'm sorry, glad we did not hit enter. Multiply row 3 by 1 divided by -2. Alright, that. Row 3 multiplied by -1/2. And we have that. Right. As you see, we do have the 1 in the step, not diagonal, but at least you go down to the right, down to the right. Not necessary on the diagonal. Anyway, like I said, we can stop here already, because no x, no y, and no z cannot give you anything else than 0. So this has no solution already. But just to complete the reduced row echelon form, we'll turn this to a 0 and that to a 0, where the leading one is going to be here. So we do that. Opposite to that number times row 3, add and replace to row 1. And opposite to this number, multiply to row 3, because it has the leading one. We add and replace to row 2. Right, we do those 2 operations. Right, enter to continue. Option number 4. Multiply row 3 by -14, add to row 1, and multiply, still option number 4. Multiply row 3 by 5, add to row 2, and replace to row 2. And we have that. Now we check. We have 1, 0, 0. First column is good. Second column we have the 1, 0, 0, which is good. We cannot do anything with this column, so we're going to skip this. On the next one we have 1, which is good, and go down to the right, so that's also good, and those 0, 0, which is good. So this is in the RREF form. We can write the solution from here. Notice that we have this row. If we write it out, it will be 0x plus 0y plus 0z equal to 1. Obviously, we have nothing on the left side cannot equal to 1, so we have no solution. Right, so that is where we have no solution. Remember, from the first video where we're using the inverse, we cannot tell if this system has no solution or infinitely many solutions. If we use the Gauss-Jordan elimination, definitely here we can say it has no solution. If we have 0, 0, 0 and also 0 here, then that will be infinitely many solutions, which is not in this case. In this case we have 1, so no solution. If this is a 0, it will be infinitely many solutions. We have 2 examples on the Gauss-Jordan elimination, and I hope that helped. Thanks for watching.